the things that Marvin convinced us of in his earlier PPP presentation is the number of features that PPP is going to bring to the equation, especially when you consider this and compare it against HDLC. Well, in this video demonstration, let's watch Marvin as he configures some peer neighbor route features and compression.
We're going to take a look at some of the additional PPP options and features. One of those we have is the peer neighbor route. So the concept is that in the negotiation, having information passed back and forth, PPP negotiation, learning information about the other side. Now, in this case, starting off with just our basic setup here, take a look at our running config here. Now on our serial interface, we have an address 155.20.45.4. Moving over to router 5, who's the other end of our connection. Address 155.20.45.5. Now in this case, both ends of the connection are on the same logical subnet. So we're going to go ahead and just ping across. And we have connectivity across. Now, that may not always be the case. And with the PPP and the peer neighbor route, you could have two different addresses and completely different subnets configured. So we're going to go ahead and just change the subnet on this side. And just give it a different address. And an address of 5.5.5.5. We're going to go shut down our interface. And go ahead and bring it back up. Now, the peer neighbor route allows me to still have connectivity. Normally, if I have someone on the other end of a link that is a completely different address, I'm not going to know to send information out for that address out that interface. As far as I'm concerned, this serial interface is just the 5.5.5 network. Now looking at my routing table here, in this case having a connected network, we see we have a connect network for the other end, the 155.20.45.4, showing as a /32. So we have reachability to that. We can then ping the other side. And we have success. If we take a look at the connection on router 4, take a look at router 4's routing table. And again, having the information there, having the information for router 5, again as a /32, that information exchanged during the negotiation. Now what if I didn't want that, or I didn't want that feature on there? On the interface itself, the command is peer neighbor route, so I can do a no peer neighbor route. And make sure I'm on the correct interface here. And I'm going to go ahead and shut down that interface. And bring the interface back up. Alright, so we brought the interface back up. Take a look at the routing table. In this case, not showing that information. So the no peer neighbor route on the interface telling us to not install that route. So I try and just ping that address. of the other side. In this case, not getting a response. Now if we move back over to router 5, now on this side we did not make the change. So on router 5, since we did not make that change, he still sees that information locally. So on router 5, we didn't put in the no peer neighbor route on the serial interface. Because of that, he shows that as a /32 as a directly connected still. Now if we try to ping that address, we're not going to get success. Now we're going to go ahead and just kick off an extended ping. And just to verify that the traffic is actually getting to router 4, but router 4 just doesn't know how to send it back. So we did a ping with a repeat count there. And on router 4, we're just going to turn on debug. And debug IP-ICMP. And router 4, we show it receiving information, trying to send out a reply to that destination, but again, because it doesn't have a local route for that remote network, unable to send it across. So in this case, taking a quick look at that peer neighbor route, and again, some people like to remove it. You can run into cases where removing it can cause problems with a loss of connectivity. As long as you don't mind having those extra /32s around, shouldn't have too much issue there. So we're going to go ahead and switch back, turn that back on. And bring the interface back there. And again, in this case, interface came back up, sending those replies out. And again, with that peer neighbor route, able to talk back and forth, even if the two networks are different. So next we're going to take a look at another feature here. We're going to go ahead and switch the address back on router 5. And we're going to take a look at some compression options. Now, we have compression available with HDLC. However, with PPP, we have more options we can use for the compression protocols, or algorithms is a better way to put it. And getting into actual PPP compression itself, looking at different options we have here, LZS, Predictor, Stack, and MPPC. So different options there. We're going to go ahead and just turn on some compression here. And we're going to turn on stack compression on both sides. So we have our compression turned on both sides. And we're going to go ahead and generate some traffic. And a little bit more traffic than that. And we're going to turn this debug off here. debug's off, kick off some pings, see a bunch of and take a look at our compression statistics. In this case, showing we have information set up, software compression, uncompressed bytes, 120,000, compressed bytes, 23,000, so ratio roughly 5:1 for compression. Now in this case, showing information, we do also have the show compressed detail, and getting into showing us the actual items used, the protocol used for compression. In this case, showing the LZS in both directions for compression and decompression. We're going to go and just change that on router 5 and change that to a predictor. And switch back to router 4. Generate some more traffic here. Again, pulling up statistics. Here we show different algorithms used. So we have the predictor used for the compression and the LZS used for the decompression. So again, not required to use the same one in both directions, able to use different items in different directions. Kick off some more traffic. And pull up these statistics here. And again, showing the compression types we have. Compression of stack on one side and compression of predictor for the other.